apart from the dwarf planets, another set of celestial bodies that we have are satellites. So when it comes to the satellite, is an object that orbits or circles around a bigger object. So now see, satellite is a commonly confused term. Satellite can be natural and satellite can be man-made. So here strictly we are not talking about the man-made satellites, we are talking about the natural satellites. Now satellite by definition is any celestial body that is revolving around any other celestial body. So moon becomes the satellite for the earth, but technically in strict terms if you talk about it, earth is the satellite of the sun. But since we have a separate set of definition that has been given to the planets, that's why we do not call earth as a satellite, but we call another celestial body that are revolving around planets. Those celestial bodies have been named as satellite. So for general understanding, just remember that when we discuss these satellites, we are actually talking about the objects which are, or the celestial objects which are revolving around any planet. But by definition, satellite can be any celestial body that is revolving around any other celestial body in the universe, right? So coming to the satellites, if you look at this picture, we have all the satellites or the important satellites for all the planets listed out here. And just look at this. We talked about Ganymede, which is the largest moon in the entire solar system. Compare that to moon. Moon also is a big satellite, but not as big as Ganymede. And this is the size of the earth. The next celestial body that we have in our solar system are comets. And what are comets? Comets are basically snowballs of frozen gases, rock and dust, which are very small. So what the comet contains are dust, ice, carbon dioxide, ammonia, methane, and all the other gases that are possible. So what you have seen whenever you look at a comet, for example, this is the most famous comet that we have, that is Halley's comet. So what you see is that it has a head and it has a tail. So if you look at this point, when the comet comes very close to the sun, it would heat up and it would spew gases and dust into a giant glowing head larger than most of the planets, and the dust and the gases form a tail that stretches away from the sun for millions of kilometers. So this is what happens. And if you look at a comet, these basically are the parts of a comet. You have a nucleus, you have something called as a coma, you have a gas tail, you have a dust tail. So all these are important parts of a comet. And apart from that, you have something called as a hydrogen cloud. So what are these? So first thing, when you look at this part, when you talk about a nucleus. So nucleus is, you can say, relatively solid and stable, mostly icy and gas with small amounts of dust and other solid. So if you have, so solid and stable, mostly ices and with mainly gases but with small amounts of dust and other solids. Then if you talk about coma, the second part of a comet that we are looking at here, it is basically a dense cloud of water, carbon dioxide and other neutral gases that surround the nucleus. So what it contains is carbon dioxide, water and some of the other gases. Then apart from that, you have something called as a hydrogen cloud, which you cannot see here in the diagram, but it is something which is very huge, millions of kilometers in diameter, but very sparse, and a kind of nucleus or a kind of envelope that surrounds the nucleus. So that's why it is not seen in the diagram here. The next part of the comet that we look at here is dust tail. So when you talk of dust tail is something which is millions of kilometers long, approximately 10 million kilometers you can say, and it comprises of gases and small sized dust particles which are driven off the nucleus due to escaping gases. So what we see, when you see from the naked eye, this is the most prominent part of the comet that will be visible to you. Apart from that, you have something called as a gas tail, or also called as an iron tail. So gas tail or iron tail can also be several hundred kilometers or several hundred million kilometers long and is composed of plasma and is laced with rays and streamers that are caused by interactions with the solar wind. So if you remember solar wind, we had talked about the fact that it hinders the atmosphere of many of the planets, it interacts with the magnetic fields of other planets, and it is also responsible for forming the gas or the iron tail on a comet. Next celestial body that we have here are asteroids. So when you talk about asteroids, they are what? They are small airless rocky worlds which are revolving around the sun and are too small to be called as a planet. So they cannot be defined as a planet. They are a separate set of celestial bodies that you have in the solar system. Now, when we talk of asteroids and what they are composed of or how they were made, you can look at this point. They are leftovers from the formation of our solar systems approximately 4.6 billion years ago. Early on, the birth of Jupiter prevented any planetary body from forming in the gap between Mars and Jupiter, causing small objects that were there to collide with each other and fragment into asteroids that are seen today. So this is how the formation of asteroid is supposed to have happened. So now when you talk of asteroids also, the most important fact is that most of the asteroids are located between Mars and Jupiter. But apart from these asteroids, there are some other asteroids also that we have, something which is called as a Trojan asteroid. And a Trojan asteroid is basically a kind of asteroid which gets associated with one of the planets. So instead of being in the region between Mars and Jupiter, they would be associated with one of the orbits of any of the planets. For example, Earth. Earth has a Trojan asteroid called 2010 TK7. This is a Trojan asteroid of the Earth. It is associated with the orbit of the Earth around the Sun. So how that happens, we'll have a discussion on it little later. Once we start the space technology, the second part of this module, we'll discuss that there. So this is what asteroids are. Apart from asteroids, you have something called as meteors, meteoroids and meteorites. So don't get confused between these three terms. What exactly they mean? If you look at this piece of information, a meteoroid is a small rock or particle of debris in our solar system. They range in size from dust to around 10 meters in diameter. Apart from that, you have something called as a meteorite and a meteor. So this meteoroid, when it starts to fall on the surface of the Earth, when it is in the atmosphere of the Earth, at that point of time you call it a meteor. Most of the meteors, they would burn up in the atmosphere itself because of such a huge amount of air resistance that we have in our atmosphere. So they would burn out, and this is something that you would see as a shooting star. So most of it would burn out and they would be called as meteors. But some of the meteors would fall on the surface of the Earth, and that is when they would be called as a meteorite. So let's say if the meteor did not burn out completely in our atmosphere and it fell onto the surface of the Earth, then that rocky material, that celestial body that fell onto the surface of the Earth would be called as a meteorite. So if you look at this animation, this will give you a clearer picture about what exactly this is. So if you look at this transition, this transition shows you, if you look at this particular diagram, this is a meteoroid. Then once it enters the surface of this Earth, it becomes a meteor. And finally, if it falls on the surface of the Earth, it becomes a meteorite. So this is a meteoroid, this is a meteor, and then finally this becomes a meteorite. I hope this brings in a clearer picture for you between the distinction between the three terms that we are discussing here. Very important topic from Pradip's point of view. So I'll just let you watch it one more time and then we'll move further. So this is how the things happen. This is how the transition happens. The next set of celestial bodies that we have are something that lie in the Kuiper belt. What is Kuiper belt? It is a disc-shaped region beyond Neptune that extends from about 30 to 55 astronomical units. Again, Pluto is the best known larger object in the Kuiper belt until now. So what is Kuiper belt? Kuiper belt, basically if you look at this particular diagram, a belt that lies beyond nucleus up to the edge of the solar system, which would have hundreds of thousands of celestial bodies, many comets, trillions of comets can be present in this belt. And Pluto, if you look at this, Pluto lies in the Kuiper belt, that is trans-Neptune region. Next, the last one that you have at the edge of the solar system is something called as an Oort cloud. So Oort cloud is theorized small icy objects that lie beyond the Kuiper belt. If you look at this particular diagram, you have heliosphere here. Heliosphere is the region up to which you would have the influence of the sun or the influence of the magnetic field of the sun. So the solar winds of the sun can have some effect up to the point you have the heliosphere. So after heliosphere you have something called as interstellar space, where we are supposed to have nothing, and then you finally have Oort cloud. So Oort cloud basically is, you can say, the no man's land between our solar system and the other systems that exist in our Milky Way galaxy. So if you look at this Alpha Centauri is one of the systems of stars that is just beyond our solar system. Alpha Centauri, or one of the stars of this particular system, which is called as Proxima Centauri, is the closest star to our solar system. So this is what Oort cloud is, that it is a theorized shell of icy objects that lie beyond the Kuiper belt. So they are supposed to be somewhere between 50,000 to 2 lakh astronomical units. And finally, the outer limit of Oort cloud, as we all talked about, defines the boundary of the solar system and the extent of the sun's heliosphere or heliosphere.